Gravitational acceleration and free fall. One day, Isaac Newton is sitting under an apple tree when an apple falls from the tree. He starts to think about the force that causes the apple to fall, then he realizes that the apple falls due to gravitational force. All objects around us are pulled towards the center of Earth by Earth's gravitational force. Gravitational force causes an object to always fall downwards. An object such as the apple that falls due to Earth's gravitational force will experience gravitational acceleration. The symbol used to represent gravitational acceleration is a small letter g. What is the value of g? How can we determine the value of g in the laboratory? Let us carry out an experiment. This experiment is to determine the value of gravitational acceleration by using a ticker timer. Observe the setup of the apparatus. The ticker timer was clamped vertically on a retort stand. A 1 meter ticker tape was inserted into the timer with a weight of 50 grams placed hanging. The ticker timer was switched on and the weight released. The weight fall freely to the floor. The ticker tape was then analyzed to obtain the value of gravitational force, g. This is the ticker timer. The first step is to measure the displacement of the first tick, let's say x1. The second step is to measure the displacement of the final tick, x2. Remember, the time for each tick is 0.02 seconds. From this we can calculate the initial velocity, x1 divided by 0.02. By using the same formula, we can calculate the final velocity. In the last steps, we can determine the gravitational acceleration, which is equals to the final velocity minus the initial velocity divided by the time interval. The time intervals is equals to 5 ticks multiplied by 0.02, which is 0.1 seconds. In this example, the first tick is 1.3 centimeter. So, the initial velocity is 1.3 centimeter, divided by 0.02 seconds, equals to 65 centimeter per second. The displacement for the fifth tick is 3.2 centimeters. So, the final velocity is 3.2 centimeters divided by 0.02 seconds, equals to 160 centimeter per second. The gravitational acceleration, g, is 160 minus 65 divided by time interval, t, which is 0.1 second. Finally, g is equal to 950 centimeter per second, Convert the unit centimeter to meter, this is equivalent to 9.5 meter per second, What happens if the weight in this experiment is manipulated? No matter what weight are used, the gravitational acceleration remains the same. The value of gravitational acceleration, g, on the surface of Earth is 10 meters per second. Is the value of the gravitational acceleration obtained in this experiment the same as the actual value of g? At different points on Earth's surface, the free fall acceleration, g, ranges from 9.7 to 9.8 meter per second, depending on altitude, latitude, and longitude. What is a free fall? An object is said to experience free fall if it falls due to the effects of gravitational force only. For example, a sheet of paper does not fall freely because its motion is affected by air resistance. Objects falling freely fall with the same gravitational acceleration no matter what their mass and shape are. Actually, free fall only occurs in a vacuum, that is in a space with no air. In a vacuum chamber, a chicken feather and a tennis ball that are released from the same height will reach the bottom of the chamber simultaneously. If an object experiences a free fall, what is the motion looks like? What are the changes in velocity along the free fall path? Now, let us study the free fall in more detail by using linear motion graphs. This is a velocity time graph. Axis Y is velocity. Axis X is time in second. Before being released, the velocity of the object is 0. The object is stationary. When the object is released, the velocity of the object increases uniformly. The gradient of the graph is equals to the acceleration of the object. The acceleration is known as gravitational acceleration. This is a displacement-time graph. Axis Y is displacement in meter. Axis X is time in second. Before being released, the displacement of the object is 0. The object is stationary. Once the object is released, it falls with a low velocity. This can be seen in the small value of the gradient. During free fall, the object falls with higher velocity than its initial velocity. This can be seen in the greater value of the gradient of the graph. What is the shape of the linear motion graph if the object moves against gravity? For example, when someone throws a ball upwards. Observe the velocity-time graph. When thrown upwards, the object starts to move with a velocity of v meter per second. The velocity of the object decreases as the object moves upwards. The gradient of the velocity-time graph is negative. At maximum height, the velocity of the object is 0. Observe the displacement-time graph. When thrown upwards, the object starts to move with a velocity of v meter per second. At the same time, the displacement of the object changes. At maximum displacement, the velocity is 0, where the object stops momentarily, before it falls back down. We have discovered what is gravitational acceleration, g value. The g value can be calculated using a ticker tape. The gravitational acceleration of all object is about 10 meters per second. Free fall of an object can be represented using a velocity-time graph and displacement-time graph. The gravitational force that we experience applies in designing airplane and space travels. That's all, thank you for listening.